The next question of CODECHEF starters 118 is subset GCD. So basically in this question, we are given with N and K. So basically we have a set which has numbers 1, 2, so on till N in this set. So from this set, we need to pick a K-sized subset such that the K-sized subset that we pick should have the maximum GCD possible. So in case if there are multiple answers, multiple K-sized subsets, we can print any one. So we need to output such a K-sized subset which has the maximum possible GCD in this set. So if we look at the constraints, test cases can be in the range 1 to 10 power 5 and K is less than or equal to N and N can be in the range 1 to 10 power 5. Right? And it's guaranteed that summation of N over all test cases won't exceed 2 into 10 power 5. So let's see how we can solve this problem. So firstly, in this, we know that for any sequence, for any subset, for G to be the GCD of the whole subset, in the subset, every element should be a multiple of G only, right? Multiple of G only. So from this, if we see, then we can observe that we know number of multiples of any element. Let us assume that G's are GCD. Then number of multiples of G that are present in the range of numbers 1 to n with 1 to n are floor part of n by G. Right? So now we want this greater than or equal to K. So the equality is floor part of n by G should be greater than or equal to K. Because floor part of n by G will tell us the number of multiples. So the number of multiples of G should be at least K. Right? Then only then we can say that we can form a K-sized, at least K-sized subarray. We can form K-sized sub set from 1 to n numbers. So now our aim is to calculate the maximum G which satisfies this equality. So for that we can iterate a loop. One way is iterate a loop and then iterate a loop, fix G in the range 1 to K, 1 to N, let's say, because G can't be more than N. So we can iterate a loop where G ranges from 1 to N and then check the maximum G which satisfies the equality. So this way we can find out the maximum G which satisfies the equality. Or one more way without iterating a loop is to we iterate a loop according to the constraints, it's fine for this question. And there is a way to find the same thing out without iterating a loop. If we just look over this and reformulate this, we can observe that the maximum G that we can achieve such that number of multiples of G from range 1 to n are greater than or equal to K is floor part of n by K. Right? If you just observe this equality and then deduce it, then we can observe G is equal to absolute G is equal to floor part of n by K. This is the maximum G that we can achieve. So let's say we deduce G either by this or by iterating a loop and finding out the maximum G which satisfies the equality. Then we know that for this G, this particular G, we know that this is the maximum possible G among all the subsets of among all the k size exactly k size subsets of the given set of numbers 1 to n. So now we need to print any one k size subset which has a GCD G and G is deduced. So what we can do is we can just print G into 2 so on till G into k, right? Because we know that as we know what is k into floor part of, we know G is floor part of n by k. So we know that k into floor part of n by k is less than or equal to n, right? So that is why always k elements, k multiples of G exists, because that was our equality which we deduced. So once we find out the G, we can just print G into 2, so on till G into k. So now if we observe the GCD of this will be G, right? Because all these are just multiples of G. So if we look at the time complexity of this, if we use a loop and then find out the G from the maximum G from the equality, using the equality, then the time complexity will be big O of n plus k. Else, if we just formulate it by floor part of n by k, then it would be big O of k only. Right? So we can either implement it in this or this time complexity. And space complexity here, we can implement it with a space of big O of k or big O of 1. So it becomes big O of 1 if we just print G into 2, so on till G into k. Or if we store it in a list and then print, it would cost us big O of k. So these are the two different ways to implement it with different time and space complexity. These are per test case. And big O of n plus k, like time complexity of big O of n plus k, big O of k, both are allowed, and space of big O of k and big O of 1, both are allowed, according to the constraints and the given TL of the problem. So it's mentioned that summation of n over all test cases won't exceed. If we look over, it is summation of n over all test cases won't exceed 2 into 10 power 5. So we can assume one test case is given with n, we can assume two test cases are given with n 10 power 5 each. And k is, however, less than n. So even k should hold this because it's always given as less than n. So this time complexity and space complexity are sufficient enough for the given TL and space limit for the problem, memory limit for the problem. So this way we can solve the problem.